So the quantum mechanical model replaced the Bohr model in the early 20th century, so early 1900s. This was a revolutionary model because in it the electrons do not behave like particles flying through space. And it's a little hard to get your mind around. So instead of orbits, we have orbitals. And the similarity in the names is both good and bad. Orbitals are places that an electron can be, but they are not circular orbits. Okay? They represent probability maps that show a statistical distribution of where an electron is likely to be found. So let's think about baseball. It is baseball season. Kids playing baseball. We understand what baseballs do. When you throw a baseball, you can predict, pretty well where it's going to go, even if you've never had a physics class, just by experience with the law of gravity and throwing objects at your mother when you were small, right? So the pitcher pitches the baseball, and the path of that baseball can easily be traced from the pitcher to the catcher. And a good pitcher can throw the ball exactly the same way every time if he wants to, and hit the catcher's mitt. Very predictable. We understand that. That's called Newtonian physics after Isaac Newton. We understand it. It's the physics of everyday objects that are large enough to see moving. Electrons do not behave in that way. If you were able to pitch an electron to the catcher, it would land in a different place every time. You set it in motion with the same trajectory, the same momentum, the same velocity, and it does not go to the same place. That doesn't work with life-sized objects. It only works with the extremely small. What happens is something like this. That's some sort of distortion on the aspect ratio of this picture. I should fix that. So if that electron was thrown at the catcher, about 20% of the time it would fall within this circle here, 40% of the time it would fall within this circle, and 70% within this circle. Now sometimes it would, hit this guy square between the eyes, right? Because they're really small, they're just going to go right through that netting and hit people, right? Or it could go over here or over there. I mean, it's unpredictable. You can say, well, it's probably going to come within this region, but maybe not. A little bit like throwing darts. If you're not good at darts, you throw the dart, you're never really sure where it's going to go, and you don't want to hang the dartboard on a wall that you care about because you're going to miss the board a lot, right? So we have a probability map of where the electron is. Electrons and photons both exhibit wave-particle duality. In some ways they act like a wave, and in some ways they act like a particle. We're more comfortable with thinking about electrons as particles and light as waves, but they actually behave in much the same way. So an orbit from the Bohr model is a circular path showing the electron's motion around a nucleus. It's predictable, it's nice, it's friendly, we like it. It's not true. An orbital is a probability map showing relative likelihood of an electron being found at various locations. It's a volume. So within this sphere is where the electron is likely to be. It's completely unpredictable. You cannot predict where an electron is at any given moment in time. So, any questions?